Now talking about the combination of lenses, which mean a combination of two convex lenses, right? The combination of a two lenses or a convex lenses. Right, for this I was gonna draw a diagram here. So let's just take a shape here. So let's just take this shape and increase it. Okay, let's let it go. So first of all, let's draw a straight line here. So this is a basically straight line. Two lenses that are in contact with each other. For instance, this is a two lenses, lens 1. This is a lens 2. These both are in contact with each other. This is my mistake that I just left some space between that, but the glad space, right? So this is basically an optical center, which is O. This is a focal length F. Object is placed somewhere here. For instance, object is placed O. Extend the line by yourself. This is an F. Okay, this is a F, and then F1, and that's F2, right? Okay, so what exactly happens here is that, wait, let me just take the, yeah, this color. Okay, so the first laser ray, for instance, this is an object. For instance, the rays passes through an object. After it passes through lens. This rays wants to converge at this point, but due to passing through the second lens like this converge at a point right here. So for instance, the rays passing straight to the principal axis is formed in here. So again, the rays passes through the second lens is converges point. The image that is formed here. This is the image which is real inverted and yeah, this is real and inverted. Real, this is real and inverted and magnified. Real, inverted and magnified. Real and inverted. This image is real and inverted. It is from this point. But as you can see, this is a combination of a lens. So this image acts as an object for the second lens. This image of first act as an object for the second one. Image of first lens act as an object for the second. Act as an object for the second lens. Act as an object for a second lens, right? So lens image of first lens acts as an object for second lens. So this is a real inverted. So we know that now we can say that the distance from an optical center to this object is p. This is a p distance, and the distance from optical center to this image is q center, right? So here the image I1 is formed. This is I, right? Now what happened is rays forms an image here, which is I naught. For instance, the object of first acts an image. Image of first acts an object. So the second one, I naught image is formed. It is virtual, erect, and highly magnified due to extended rays that we're gonna form here. This extended rays are formed something here like this. The space passing, for instance, this going extended forming an image here, which is virtual, erect, and highly magnified, right? So, for instance, now we're gonna write a formula taking in help of a thin lens formula. So we're gonna drive it. Okay. Okay. So we know that the here P. Okay. So here P is equals to P. So object is equals to object, right? Q is equals to Q, right? Q is equals to Q, and F is equals to F, right? For first lens, F is equals to F. So we know that the 1 upon F is equals to 1 upon P plus 1 upon Q. 1 upon F is equals to 1 upon P plus 1 upon Q. 1 upon P plus 1 upon Q plus 1 upon Q, right? So this is a focal length, right? For instance, right, this is an equation number 1. So talking about the second equation, we know that the 1 upon P here, P is equals to P naught, right? For instance, the image of first action, the action object for the second one, Q is equals, P is equals to minus Q, because this is a virtual image object, right? Q is equals to Q naught and F is equals to F naught. Q naught and F is equals to F naught. F is equals to F naught, right? So what exactly here happens is that 1 upon F naught is equals to 1 upon P plus 1 upon Q. 1 upon F naught is equals to 1 upon P plus 1 upon Q, right? 1 plus 1 upon Q. So here when I F1, so this is equation number 2, write it here. This is 2. Add 1 and 2 equation here. So let's adding 1 and 2. So let's just move a bit down so that we can see each and everything. So yeah. Okay, let's go. 1 upon F1 plus 1 upon F2 is equals to 1 upon F2. 1 upon F1 plus 1 upon F2 is equals to 1 upon f, which is the equivalent length. So focal length of a equal length is the sum of the focal length of the two lenses that are in contact with each other, right? So this is basically a formula for the combination of a thin lenses. 1 upon f is equal to 1 upon p plus 1 upon q.